So amines are alkyl or aryl derivatives of ammonia, and ammonia has got a formula NH4. Amines are alkyl or aryl derivatives of ammonia. In nature, they occur among proteins, vitamins, alkaloids and hormones. So the alloalkane or benzyl halide is heated with a concentrated solution of ammonia in ethanol in a sealed tube at 373 Kelvin. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence, Mysuru. So today we are going to start a new chapter, that is amines. So in this session, we are going to study about what are amines, then structure of amines, then classification of amines, and then nomenclature, then preparation of amines, then that reactions which includes reduction of nitro compounds, then ammonolysis of alkyl halides, then reduction of nitriles, then reduction of amides, then Gabriel synthesis, then Hoffman's bromide reaction, and also about physical properties of amines. So let's start with what are amines. Amines are alkyl or aryl derivatives of ammonia. In nature, they occur among proteins, vitamins, alkaloids and hormones. Then amines are starting material for the synthesis of many substances like polymers, dyes and drugs, etc. Then amines are obtained by the replacement of one or more hydrogen atoms of ammonia by alkyl or aryl groups. So ammonia has got a formula NH3, wherein this hydrogen atoms are replaced by either alkyl or aryl groups. So let us see the examples here. So in this, NH2 and CH3 are bonded together, wherein one of the hydrogen atoms from ammonia is replaced by alkyl group, that is CH3 group. So therefore, this compound has a name methylamine. So this belongs to amine compound. Next is the same thing. Two hydrogen atoms from ammonia are replaced by two alkyl groups. So therefore, it has a name dimethylamine. And in the next example, all three hydrogen atoms from ammonia are replaced by alkyl groups. So it is having a name trimethylamine. Instead of alkyl groups, aryl groups also can be substituted. Next, structure of amines. Let us see. The nitrogen atom of amines carry an unshared pair of electrons, and in amines, nitrogen is usually sp3 hybridized. So aliphatic amines have a pyramidal shape that is approximately tetrahedral in shape. Each of these three sp3 hybrid orbitals of nitrogen overlap with the orbitals of hydrogen or carbon depending upon the composition of the amines. So the fourth orbital of the nitrogen in all amines contains an unshared pair of electrons. So due to the presence of unshared pair of electrons and also because of lone pair bond pair interaction, the angle between carbon, nitrogen and any other group, whether it consists of a carbon or any other hydrogen atom, or it can be alkyl or aryl group, it is less than 109.5 degree. So for instance, it can be of 108 degree in case of trimethylamine. So because of the presence of lone pair of electrons and this nitrogen carries sp3 hybridization, and then this lone pair of electrons will be the responsible for the bond angle of all three hydrogen atoms move towards downward. So therefore, the bond angle between hydrogen and hydrogen will be around 107 degree. So therefore, this is responsible for the tetrahedral shape in the structure of ammonia. If there are more bulkier, and the shape would be distorted from tetrahedral shape. Here it is again tetrahedral shape of trimethylamine. So next is about classification of amines. So amines can be classified into primary, secondary and tertiary amines depending upon the number of hydrogen atoms of ammonia that have been replaced by alkyl or aryl group. So here is ammonia structure, that is NH3. If one hydrogen atom is replaced by the alkyl group, it belongs to primary amine. If two hydrogen atoms are replaced by alkyl groups or aryl groups, then it belongs to secondary amine. Then if three hydrogen atoms are replaced by alkyl or aryl groups, then it belongs to tertiary amine. And then So here are some of the examples. Say for example, trimethylamine, N, N dimethyl propane 1 amine, and then ethyl methyl amine. Classification of amine includes aliphatic amine and then aromatic amine. So here is about aliphatic amine. So an amine in which nitrogen is bonded to alkyl groups are known as aliphatic amine. So here is an example. Alkyl group is CH3, so therefore it is methyl amine and it belongs to primary amine. Next is dimethylamine because two alkyl groups are present here, so therefore it is secondary amine. That is because it is replacing two hydrogen atoms from ammonia. Next, 3 hydrogen atoms are replaced by 3 alkyl groups, so it belongs to aliphatic amine. So that is trimethyl amine, tertiary amine. Then next is about aromatic amines. So amine in which nitrogen is bonded to one or more aryl groups. So instead of alkyl, here it is an aromatic ring. So therefore, aromatic ring bonded to NH2 group is having a name aniline, and this belongs to category of primary aromatic amine. Next is N-methyl aniline. So here one of the hydrogen atoms is replaced by aromatic ring and another hydrogen atom is replaced by alkyl group. Therefore, it belongs to secondary aromatic amine. Next is N3N dimethyl aniline because all 3 hydrogen atoms of ammonia are replaced by aryl and alkyl groups. So therefore, it belongs to tertiary aromatic aniline. So there is one more class of amines besides these 3 types in which nitrogen atom is quaternary. The derivatives of ammonium salt in which all the 4 hydrogen atoms are replaced by alkyl or aryl groups are called quaternary ammonium salts. So here is a general formula wherein ammonium salt consisting of NH4 plus X minus, X belongs to halogen. So these 4 hydrogen atoms will be replaced by either alkyl or aryl groups, making it NR4 plus X minus. So this ammonium salt is going to belong to quaternary ammonium salts. Example is given here, that is C2H5 5 times the N plus and then Cl minus. It's a tetraethyl ammonium chloride. It's a salt. So having a name tetraethyl ammonium chloride. So next is about nomenclature. Nomenclature includes common naming system and then IUPAC naming system. So in common system, aliphatic amine is named alkyl amine as one word, and in the secondary and tertiary amine, when 2 or more groups are the same, the prefix di or tri is appended before the name of the alkyl group. And in the IUPAC naming system, the aliphatic names are named as again alkyl amines. These names are obtained by replacing the terminal E of an alkane name by suffix amine. So the substituents which are attached to the nitrogen atom instead of the carbon of the chain are designated by the capital N. That is what we have to use, the capital N. So let us see the names of aromatic amine. How are we going to follow the rules? So the simplest aromatic amine, that is C6H5NH2, it's a basic compound, and in common system it is called as aniline. So its simple derivatives are named using the prefixes OMP, that is ortho, meta, para, or numbers to locate the substituents. While naming the aryl amines according to IUPAC system, the suffix E of arene is replaced by amine. So looking into these rules, let us see how are we able to give the names, IUPAC names for the compounds. So the first is primary compound, that is CH3NH2. CH3 belongs to alkyl group and it has a name methyl amine, and IUPAC name says it is methenamine. So from E it is replaced with amine group. Next is CH3CH, and for the second carbon atom NH2 is bonded. So it is having a common name isopropyl amine, but IUPAC name says that it is 2-propanamine. So next is CH3N-CH3, wherein nitrogen is bonded to 3 alkyl groups. So it has a common name trimethylamine, and IUPAC name is N, dimethylamine. Next is CH3CH2NH2. So it is called as ethylamine, but IUPAC is ethenamine. So next compound is consisting of 1, 2, 3 carbon atoms. So it's a long chain bonded to NH2 group. So it is having a name N-propylamine, and then it is having an IUPAC name, that is propane 1-amine. So the next compound is it consists of a aromatic ring bonded to NH2 group, and therefore it's a simplest and basic compound of aromatic amine, and it is having a compound name aniline, and the IUPAC name says it is benzene amine, because this aromatic name gives out benzene and NH2 is amine, so it is benzene amine. Next is the same aniline group consists of one more substituent, that is alkyl CH3. So it is called as orthotolidine. O represents orthotolidine, and IUPAC name is 2-methyl benzenamine. Next consists of aniline group attached to Br. So it is para-bromoaniline, because it is 1, 2, 3, 4. So the substituents are at 1 and 4 position. So it is para-bromoaniline. But IUPAC name is 4-bromobenzenamide, or it can be called as 4-bromoaniline. Next consists of 2 aromatic rings and bulky alkyl groups attached to N, that is nitrogen atom. It doesn't have a common name, but it has got a IUPAC name, that is N-benzyl N-ethyl benzene amine. So next is about reactions that includes reduction of nitro compounds. So let us see what is that about. Aromatic amines are prepared by reduction of corresponding aromatic nitro compound. So here nitro group can be reduced into amino groups by treating with reducing agent such as palladium on carbon with hydrogen gas, having a symbol palladium PD on the carbon and hydrogen gas. So zinc metal with acid or a tin with acid can be used as a catalyst for this preparation of amino group. So here is an example, that is aniline is obtained by passing hydrogen gas in the presence of heated palladium or platinum with benzene, or by heating nitrobenzene with tin or iron and then hydrochloric acid. So here is a reaction, that is nitrobenzene, nitro group attached to benzene ring. So it is nitrobenzene with a hydrogen gas and then palladium catalyst. When it is heated, it is going to replace by NH2 group, and ammonia group is being attached to the benzene ring. So it is aniline being produced from this reaction. Next, same nitrobenzene with 6 atoms of hydrogen, but the catalysts are different, that is tin plus concentrated HCl, or you can use iron plus concentrated HCl. It is going to produce aniline plus water molecules. Next is ammonolysis of alkyl halides. When an alkyl or benzyl halide is allowed to react with an ethanolic solution of ammonia, it undergoes nucleophilic substitution reaction in which the halogen atom is replaced by an amino group, that is NH2 group. So a chemical reaction in which cleavage of carbon and halogen bond of an alkyl or an aryl halide by reacting with a molecule of ammonia or an amine is called as ammonolysis. So the alloalkane or benzyl halide is heated with a concentrated solution of ammonia in ethanol in a sealed tube at 373 Kelvin, and then the reaction of ammonia with an alkyl or aryl halide leads to the formation of the substituted ammonium salt. Using that ammonium salt, the excess of ammonia removes a hydrogen atom from an ammonium ion, leaving it as a primary amine. And therefore, the primary amine thus obtained behaves as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines, and finally quaternary ammonium salts. So here is a basic reaction wherein it includes ammonium salt, that is RNH3 plus halogen X. When it reacts with ammonia, it is going to produce ammonium compound along with ammonium salt. Then here is a reaction or a general equation wherein it shows the primary, secondary and tertiary amines, and also about quaternary amines, how are they produced, including that alkyl halide or aryl halide. The free amine can also be obtained from the ammonium salt by the treatment with a strong base. So instead of strong acid, we can also use strong base to produce amino compound. So here is an ammonium salt with strong base, that is sodium hydroxide. It can produce alkyl amine. It can be alkyl amine or aryl amine along with a salt, also with a water as a byproduct. So here is an example of producing primary, secondary and tertiary amines, wherein C2H5, that is chloroethane, wherein HCl is been removed on adding of amine group. So it produces ethanamine, and on further reacting with C2H5Cl, so that is with ethanamine and ethyl chloride, and on the removal of hydrochloric acid, it is going to produce N-ethyl ethanamine. So here two ethyl groups are present attached to the nitrogen group, and again on reacting with ethyl chloride, one more molecule of HCl is been removed to produce N-N diethyl ethanamine. So next is about reduction of nitriles. So nitriles can be reduced by lithium aluminium hydride, that is LiAlH4, or by catalytic hydrogenation to primary amines. So nitrile having a general formula RC triple bond N. On reduction with hydrogen or a nickel catalyst, or we can use sodium mercuric metal in the presence of ethyl alcohol, it can produce primary amine. Let us see the example, that is methane nitrile. So alkyl group is here methane. So in the presence of the same catalyst, it is going to produce ethane amine. Next is second example is ethanamine, that is two CH2 groups are added to it, and therefore with the same catalyst, it is going to produce propyl amine. Reduction of nitrile by using sodium in alcohol is called Mendes reaction. So general formula RC triple bond N in the presence of hydrogen and then sodium dipped in alcohol, it is going to produce primary amine. And then let us see the example, that is methane nitrile. In the presence of sodium in alcohol, it is going to give ethane amine. So next is about reduction of amides. So amides yield primary amines on reduction by lithium aluminium hydride. Therefore, the general equation says amine in the presence of LiAlH4, lithium aluminium hydride, and also water, it produces primary amine. Let us see the example. Here acetamide is taken as an example, having a formula CH3C double bond O, which is bonded to NH2. In the presence of the same catalyst LiAlH4 and the water, it produces ethyl amine as a compound. Next is Gabriel synthesis. So Gabriel synthesis is an organic chemical reaction in which primary alkyl halides are transformed into primary amines using potassium phthalimide. So the potassium phthalimide on treatment with alkyl halides gives N-alkyl phthalimide, which on hydrolysis with a strong alkali like sodium hydroxide or 20% of hydrochloric acid, it gives pure primary amine. So here is a general formula of phthalimide. Then in the presence of either KOH or sodium hydroxide, it can be any strong base. So it produces ammonium salt here, and then on the removal of K and X, that is potassium and halide, that is potassium halide, it is going to produce N-alkyl phthalimide. So let us see the example by taking N-alkyl phthalimide here. So N-alkyl phthalimide in the presence of sodium hydroxide, it produces sodium phthalate as a salt intermediate component, and then also along with that primary amine as a main product. Next, let us see the example here. Taking phthalimide in the presence of strong base, it produces potassium phthalimide. So it is bonded with ammonium group, that is nitrogen group. Then in the presence of methyl chloride, it is going to produce N-methyl phthalimide. So therefore, this CH3 will get bonded to nitrogen group, and then K plus and Cl will react and produces byproduct KCl. Next is N-alkyl phthalimide with a strong base sodium hydroxide. It is going to produce sodium phthalate, that is sodium salt of phthalide, and then along with that methyl amine is also the product that is going to be obtained by this reaction. Next is Hoffman's bromide reaction. So the method for the preparation of primary amines by treating an acid amide with bromine in an aqueous or ethanolic solution of sodium hydroxide is called Hoffman bromide reaction. So the acid amides on reaction with bromine in the presence of alkalis at about 343 Kelvin gives primary amine. So in this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. So the same reaction has been given in an equation form, that is amine in the presence of bromine along with the presence of alkali, that is strong base, sodium hydroxide. It produces primary amine and the sodium carbonate, sodium bromide and then water. Let us see the same reaction by taking example as ethanamide, wherein when it reacts with bromine and strong alkali, it produces methanamide, that is CH3NH2 with the sodium carbonate along with the presence of sodium bromide and then water molecules as byproducts. Next, let us see about physical properties of amines. So the lower aliphatic amines are usually gases with fishy smell. So primary amines with 3 or more carbon atoms are liquid and higher members are all solids. Then let us see the physical property of about solubility. So lower aliphatic amines are water soluble because they can form hydrogen bonds with water molecules. However, the solubility decreases with increase in hydrophobic alkyl groups because of the presence of hydrogen bond. So the solubility can decrease with increase in the hydrophobic quality of alkyl group. So this is about aromatic amines. So aromatic amines are insoluble in water but soluble in ether, alcohol, benzene and other organic solvents. By considering the electronegativity of nitrogen of amine and oxygen of alcohol, also 3.0 and 3.5 respectively, the electronegativity of nitrogen and of amine and oxygen of alcohol. So we can predict the pattern of solubility of amines and alcohols in water. So alcohols are more polar than amines and form stronger intermolecular hydrogen bonds than amines due to this electronegativity difference. Due to the electronegativity difference between nitrogen and oxygen atom of amine and alcohol respectively, that is about 3.0 and 3.5, we can predict the nature or the polar nature of the amines. So therefore among butane 1-ol and butane 1-amine, butane 1-O-ol is more soluble in water because of the more electronegativity difference between nitrogen and the oxygen. Next, the physical property next is about boiling points. So all amines except the tertiary amines are capable of forming intermolecular hydrogen bonds due to the presence of polar NH bonds. The boiling points rise gradually with increase of molecular mass. Therefore, boiling point is less in tertiary amines than primary and secondary amines. So the order of boiling points of isomeric amines goes like this. That is, primary amine is greater compared to secondary amine and it is again greater than tertiary amine. Next is basic character of amines. So like ammonia, amines are bases and react with mineral acids to form ammonium salts. So this reaction shows that amines are basic in nature, not acidic. Due to the presence of unshared pairs of electrons on nitrogen atom of amine, they act as Lewis base. So based on pKb value, that is basic strength of the base, so we can decide the basic strength of amines, and lesser the pKb value, stronger will be the basic strength. So here is an example, that is amine with halogen halide. So it is going to produce salt of these two compounds, and then aniline is taken as an example to show this reaction. So in the presence of hydrogen chloride, it is going to produce anilinium chloride. So this anilinium chloride is because of HCl that is bonded to amine group. So this compound name is anilinium chloride. Next is variation of basic strength of amines in gas phase medium. So among primary, secondary, tertiary aliphatic amines, the electron releasing effect is maximum in tertiary amines and minimum in primary amines because of more of a bulkier groups. Therefore, the basic strength is expected to increase from primary amine to tertiary amine. The observed basic strength of methylamine, dimethylamine and trimethylamine has been found to follow the expected order in gas phase or in non-aqueous solvents like chlorobenzene. And what is that order is tertiary amine greater than secondary amine, and again it is greater than primary amine. For example, trimethylamine is having more basic strength compared to dimethylamine. Again, when it is compared to methylamine, it is having a more basic strength. Next, the basic strength of amine depends on the following factors, that is plus I effect, then extent of hydration by hydrogen bonding, then also about steric effect. So let us see how are these factors vary the basic strength of the amine group. So the first thing is plus I effect. So electron donating inductive effect increases the basic strength of amines by increasing the electron density on nitrogen atom. So it consists of lone pair of electrons on the nitrogen atom. So it depends on the basic strength. So therefore, more the methyl groups attached to nitrogen atom, more is the plus I effect, and hence basic strength of methylamine decreases in the order tertiary greater than secondary greater than primary. So tertiary is more basic compared to primary amine. Next is hydration effect. So basic strength of methylamines depend on the extent of hydration of methyl ammonium ions which are formed by the protonation of amines. Therefore, the extent of hydration of the cations is in the order primary greater than secondary, which is greater than tertiary. So here is a general equation of primary, secondary and tertiary. So because of the extent of hydration, the basic strength of amines goes like this: primary, secondary and tertiary. So the next effect is steric effect. So the basic strength of amines depend on the ease with which protonation of amines will take place. So the presence of bulky alkyl groups hinder the protonation, and this hindrance is called as steric hindrance. So more of the alkyl groups present in the amines, more will be the steric hindrance, and therefore the basic strength will be in the order primary greater than secondary will be greater than tertiary. So because tertiary will have more of a bulkier group of alkyl or aryl, so it will have a less basic strength. So that was about today's session. In the next session, we are going to study about alkyl amines, that is being stronger bases compared to ammonia. So until then, thank you.